feel to it.
Yeah, it's got an almost improvisational tone.
This semester on Stat 201, prepare yourself for YouTube, because we're all zoomed out. Cahoots and special guests, Tiny Brian, Puppet Shark, Evil Moobot,
I am Levi.
Morty the Rabbit, and more. Super Statistics Bros.
Hey everyone, how are we doing? I got to see Dr. Hart today, Dr. Amelia Hart, absolute all-star, absolute legend. So shout out to Dr. Hart. We'll throw some points right here. Briley, good to see you in the chat. We're going to get started with some interpretations. So what two major things do we have interpretations on? Let's put this in the notes right here. 203. Interpretations. Good to see Molly. Interpretations on the test. Interpretations. What do you have to interpret? Does anyone know what you have to interpret? We're going to try some interpretations right here. I'm going to bring up some coding. Ooh, coding. So you are not required to code. Good to see you too. But it's a lot of fun. I always think coding is fun. Remind me later. Okay, so let me close everything out. Don't save, sure. We'll figure out what we have. Okay, so you're about to see my screen. What do you have interpretations on? Is there music playing? Is there music playing? Do people hear music? Let me close out a bunch of stuff. All right, there we go. Good, I don't hear any music right now. You might have something else open, maybe another tab, but I think we're good to go. It's always nice when there's music playing. So you have interpretations for what? Kind of the popular... True. Well, let's talk about the two times you have interpretations. You have interpretations for confidence intervals, and you have interpretations for hypothesis testing. Does that make sense? So you have this right here, hypothesis and confidence. Mubot's going to drop these in the chat right here. And so for these confidence intervals, you have the proportion. So proportion, I can't spell. You have, I could have just hit that. You have the proportion. What else do you have? Confidence interval for the what? What are the other things? I'm going to label these. These are the different things you might have to interpret, and we're going to talk over them right here. We'll section the video out. But what do you have? The true mean. Yeah, we can say true proportion. True proportion, true mean. And confidence intervals always estimate the population truth. So the truth for the population. The truth for the population. They always estimate the truth for the population. That's what a confidence interval does. They do not estimate the truth for a sample. Good to see you, Abigail. They make the estimate from a sample. So we'll look at this and we'll examine this, but we're just kind of looking at the global ideas of what interpretations you have on the test, or what you'd have to know how to do. Some of these, there's 11 points of interpretations. It looks like there's 2 of them. You'll get the ones you get. And what is the last confidence interval we made? It was y bar 1 minus y bar 2. Hint. Plus or minus t, square root s sub 1 over, it'll be drop down menus. The difference in the means, the true difference in means. And so this is y bar 1 minus y bar 2. And that's the sample estimate. Or maybe we should put, it's trying to estimate mu1 minus mu2. That's what it's trying to estimate from the sample y bar 1 minus y bar 2. This is trying to estimate mu, and this is trying to estimate p. We could do estimate p from p hat. This is trying to estimate mu from y bar, and this is trying to estimate the true difference in the means, the true means, from y bar 1 minus y bar 2. That's correct, Riley. These are the sample means. So you want to understand the truth from the sample. Does that make sense? Chloe, good to see you there. You want to understand the true mean from the sample mean. You want to understand the true proportion from the sample proportion. So now we go down to hypothesis testing. And when we do hypothesis testing, we always have a starting out null value. And here's a hint for the test. We always like dropping those teaching to the test moments. True or false? The hypothesized value can be anything you want. You could say, I hypothesize 60% of students go to Taco Bell. Can I do that? I hypothesize 70% of students go to Taco Bell. Can I do that? I hypothesize students spend $1 million at Taco Bell on average. Can I do that? Can I hypothesize any value I want? True or false? What do you say in the chat? It's almost like some of those teach to the test moments. Yeah, you can. I mean, of course, but do not overthink this. You can hypothesize whatever you want. That's what I'm saying. If you know what I'm saying? You can hypothesize any value you want. There's, of course, logical boundaries. You can't say, I hypothesize students spend negative $5 billion. That's not what we're talking about. We're saying, like, the hypothesized value can be anything you think of that is logically possible. We're not saying outside of logical possibility. I hypothesize students spend a flurb of money. That's not how we're talking. The test is, it's what you want to hypothesize and see if it's true. Does that make sense? Hypothesis testing gives a null value and sees if it's true, or sees if we have evidence for an alternative, sees if there is evidence for an alt. So gives a null value, sees if can reject for alt. Does that make sense? I have to go a little like less on the words. Hypothesis testing gives a null value, what you believe is true. I believe 60% of students go to Taco Bell. And then we see if we can reject that for an alternative. What are the 3 signs of an alternative? The null has the equal sign. That's a huge note we need to know. The null has the equal sign. What are the 3 signs of the alternative? You got the this one, you got the this one, and you got the this one, which determines how we shade the curve. The less than, the greater than, and the not equal to alternative, which determine the way you shade the curve. And we'll maybe cover a little bit about those p-values again. Does anyone know the 4 hypothesis test? Hint, there's just an extra one. There's a analogous hypothesis test compared to confidence intervals because they do mechanically the same work. But does anyone know maybe the 4th one? I'll go ahead and start writing these. You can test the true proportion, and you would see the difference between p hat minus p naught and divided by the standard error of p hat. And then you could do the true mean. The independence one, yep. And this would be y bar minus mu naught. Notice that is the hypothesized, and then you go right here and you divide by the standard, or we can delete. No, that has to be in parentheses because that will get solved out right there. Good mathematical parentheses. And they divide by the standard error of the sample mean, and then we have the true difference in means. And notice you're going to use y bar 1 because you don't know the truth. So you're using the sample estimate and dividing that by the standard error. And I guess we should put this is equal to a t with n minus 1 degrees of freedom. This is equal to a z. This is equal to a divided by the standard error of the difference. And that is equal to a t with the complicated degrees of freedom. And then the chi-squared test of independence. And that is equal to sum of cell chi-squareds. Right there. Sum of the cell chi-squareds. That's how you find it right there. So how are people doing on this knowledge? This is what you've learned through the chapters. Looks like a lot, but a lot of similarities. And we're going to get to the interpretations right here. But make sure you kind of understand when to use each one of these. Or I'll give you a quick test. You ready? So do you see the numbers? You're going to tell me the number right now that you would use with what I say. You ready? So who thinks, put a yes in the chat if you're ready for the question. You're going to tell me the number by which you would use when I give you this question to see if you understand kind of the differences between these. Well, yeah, we'll show how to find the t-statistic and the chi-squared. We'll do one of those. So here we go. Randomize is ready. The question is, we want to analyze whether people went out the night before the exam. So did they go out? Yes, no, the night before the exam. And did they pass the exam, pass, fail? And then I think Benjamin's got a question. So we're analyzing, did you go out the night before the exam? Yes, no. Like, did you go out, get some dinner? Did you leave the house? Did you leave the house? Yes, no. And then did you pass the exam? And randomize already said it, number 7. Why did we say number 7? Well, it's the condition count data. So this is the chi-squared test of independence when you have two categorical variables. So take a look at some of our other videos, two categorical variables. The chi-squared test of independence uses count data. Condition 1, random. Condition 2, 10%, expected cell count, and then count data. So that's a good, and it would make a mosaic plot. A lot of times you can figure it out by the graphic, but good job right there. We'll do, let me read Benjamin's question. I know you mentioned this in class, that there are certain aspects of other units on test 3. Those are the tools and techniques. Check out yesterday's video. We did a lot of tools and techniques questions, and it's in the review 3, mentions tools and techniques. And yesterday's video has a whole section on tools and techniques going over like, and this was kind of a tool and technique question right here. Like you didn't actually have to solve anything. You might have to pick from like this. So this is kind of that. I could add more though. Like imagine I said, someone wants to make a graphic to figure out the counts of how many pets people own. Would you use a histogram, a scatter plot, a mosaic plot, or a bar chart? Someone wants to make a graphic of how many people own dogs, how many people own cats. Would you make a histogram, scatter plot, mosaic plot, or bar chart? So this is a tools and techniques question. What would you make? Histogram, scatter plot, mosaic plot, bar chart. You want to do a plot of pets people own, like iguanas. Well, be careful. And the answer is not over there. I'm asking, is it histogram, scatter plot, mosaic, or bar chart? So you're just asking people, what kind of pet do you own? So you're asking, what kind of pet do you own? It's just what pet do you own? So I might not communicate it fully. And Briley got it right there. Great job, Briley. It is just a bar chart. It's not like, do you own, people who own cats might be more likely to own dogs. That would be 2 variables. You're just asking, what kind of pet do you own? Now, there's multiple levels to it, like cat, dog, everything else. But the question of what pet do you own is just one categorical variable. It can have a lot of answers, but the answers don't make it bivariate. Does that make sense to everybody? If there's more answers, that's not bivariate. Bivariate is 2 questions. What kind of pet do you own, and how much do you spend on that pet? So what graphic, we'll go back to this here, but this is just a quick tools and techniques. Now, I'm not going to tell you this one, but think, what kind of pet do you own is the X, and how much do you spend is the Y? What would be the proper graphic for that? And I'll draw it out right here. If you can say it before I draw it, that'd be awesome. But think, what is the proper, because it will give you possibilities. So it's what pet do you own, like cat. It can be done with histograms, but not univariate histograms though. Cat, dog, or bunny, and dollars spent. So dollars spent would be the Y, and the animal would be X. It can be done with a certain type of histogram, side-by-side box plots. And if you take a look at this right here, we're down here in the side-by-side box plots. So stacked histograms would technically work, which might look more like, usually you put, you could still put dollars here, and you could put cat, dog, bunny, and then you could stack them like this and do like, bunnies are super expensive, if people didn't know. So you could do this and stack them. It's just another way to display it. Or you could do these side-by-side box plots here and show it this way. Does that make sense? Quick little aside on how to do it right there. Bunny. And so yes, stacked histograms work, or side-by-side box plots, or you could do stacked box plots. Literally to stack box plots, you just take the graphic and do this, or you could do side-by-side histograms. Side-by-siding and stacking is just a way to put together multiple graphics. So you could do side-by-side histograms or stacked box plots. It's stacking and side-by-siding are just adding more of them. So we'll try one more of these, and then we're going to go to our next thing, interpretations. And so these are, let me call this all the intervals and tests you've learned. So this is all the intervals and tests you've learned. So let me ask you this. We want to come up with possible values for how much students spend on textbooks a semester. Which one would be the proper technique here? We want to come up with possible values of how much money students spend on textbooks, like a range of values. It can be done with that. That would be if we have a theory on how much they spend. It is the true mean. This would sound more like, we believe students are spending more on textbooks this year than last year, because we would compare how much they spend this year to last year. And this would come up with possible values in interval of values. Does that make sense? So this would give you an interval of values to say, like, what is the possible true average amount students spend on textbooks? Who feels like this is starting to make a little more sense? Because if you listen to the words, you'll hear like, we want to test a value, or we have a theory on this, or we want to come up with possible values. Because like, I am 95% confident that the true proportion of students who go to Taco Bell, and that'd be number 1 right here. So that'd be number 1. Here's another one right here. Good to see you, Margaret. Another one would be, we believe that students at UT spend less on textbooks because we're awesome than that Baja Blast Pie. We believe students spend less on textbooks at UT than at Florida, and we want to show evidence of that. Which one would be used? We believe students at UT spend on average less on textbooks than students at Florida. Which one of these would be used? We believe that on average students at UT. Yep. Comparing the two means, how much do students spend at Florida versus UT? Compare the average, see if there's a difference, and see if that difference is statistically significant, that there's evidence that we spend less on average. So you can see if you can test me on one. So throw one in the chat real quick. I'll give you one, but try typing one out while I give this, because if you can come up with your own questions of these, you understand when to use them, and that's the goal. Try coming up with your own versions of like, hey, Brian, what if I tried to do this? Do you know what number that is? Because then you're figuring out how to do it. Okay, so one more, and then I'll see if anyone drops one for me in the chat, and then we're actually going to do some of these and interpret them next. Okay. I'm trying to do one I don't usually do. Oh. Last year it was reported. I'll do 3 next, yeah. Last year it was reported that at the old Taco Bell, only 10% of students went there during the semester. We go out and collect data, and we want to see if there's been an increase in the amount of students who go to Taco Bell. Which one of these is used? Last year it was reported that only 10% of students went to Taco Bell. We go out and collect data, and we want to see if there's been an increase. Which technique should be used? Last year it was reported. I might try that. I might tell my wife that we need to do that. Maybe we need to do a Stat Tool one. I've thought about doing a fundraiser, and that could be one of the goals. If we were to raise so much amount of money, Brian tries the Baja Blast Pie. I'm a big fan of Baja Blast. Close, Briley, close. So think about how we collect the data. It is a test, but if you ask students, have you been to the Taco Bell? If you ask them, have you been to Taco Bell, what kind of data does that create? So you say, have you been to Taco Bell? How would a student respond? It is 4. Yep. Because we're going to test the current to the, if it hasn't changed, it'd still be 10%. It's have you been to Taco Bell? Yes or no. And although it sounds like, well, how many have been to Taco Bell? The way the data is collected would lead to the proportion of students who have been to Taco Bell, because even though you'd say like, well, 50 students went to Taco Bell out of 200, that'd be 25%. So it's a proportion out of a certain sample size, which is X over N, which leads to P hat. X over N is P hat. So just the more you hear these, that's usually like, you're like, well, it's quantitative because it's like how many have been to Taco Bell. But the question is that it came from, have you been to Taco Bell, which creates the observation of somebody going to Taco Bell. We were talking about Arby's yesterday, cheating on Taco Bell. Okay, so we're going to change now to go to interpreting. Oh, wait, someone said, can you do one for 3? And then we're going to switch up. The true difference in the means, this would be very similar to one of the other ones I asked, where I said something like, we're trying to figure out how much on average students spend at Florida and UT on textbooks. And this would make an interval for possible differences in them. And this is a really good way to break into this. So let's go right here and do interpreting confidence intervals. Interpreting confidence intervals. You ready? So we run the test on this. I can run a real test. I'll make fake data here first, and then we'll run a real one. So we have Y bar, our test comes out, Y bar UT minus Y bar Florida, and we are doing 92% confidence, and the interval comes out -50 to -150. No, there's a reason I'm doing this. -350. Okay, good. So with this right here, the question asked was, how much do you spend on textbooks? So we're going to type in the chat confidence, and MuBot's going to give us the interval interpretation. Now there's 3 parts. You could say there's 4, but I like to say there's 3 parts to this interpretation. I am blank % confident that the true whatever the heck we're talking about is contained in the interval blank to blank. And notice how sometimes you're doing the true proportion, give it context. the true mean, give it context, or the true difference in means. So does anyone want to start us out right here? It's easy to start out. You just grab the confidence level. How confident are you? I am. And it's really good practice to write it out. And if you're watching this later, try writing it out. Try interpreting it. Try saying it out loud. You learn things by saying, I am 92% confident. And I don't want to say the rest, but remember we're talking about Florida students and UT students and how much they spend on average on textbooks. Florida students, UT students, and how much they spend on average on textbooks. I'm going to run some real data here in a moment, but for now, we're just looking at that. I am something percent confident. See if you can type it out, and then I'll read it. See, I memorize this because I say it like 10 times a semester. I am 92% confident that the true mean of the true, and so here's very close. It'd be the true difference in means between UT and Florida students. There you go. Very close. It'd be, and you could say negative because that means on average, Florida students are spending more. I am 92% confident that the true difference in means of spending between UT students and Florida students is contained in the interval. And you can throw the negatives on there. And the reason negative means more is because that is then associated with this one right here. If our interval had looked like this, what would this interval mean for textbook spending? If the interval for the two sample means was this, what would this mean? It would mean there'd be evidence that there's a positive difference, which means the math might have been something like, it might have been something like this. We might spend on average $650. They might spend on average $450. So that might be how the math was. I think, no, it needs to be that. It needs to be that. Why did I do that? Well, I want you to think about this interval. And this goes into, we just interpreted, I am 92% confident that the true difference between the average amount UT students and Florida students spend on textbooks is contained in the interval 350 to 150, which is evidence that UT students spend more because the interval is positive. We don't have that little extra on the end, but you should know it. Can you see? I can't see. You like a spirit. And so I want you to find the center of the interval. How do you find the center of an interval? We're going to do another interpretation in a moment, but this is the lower and the upper. So right now you see the lower and the upper of the interval, and Briley already did it because you just average the numbers. Which you notice right here, you notice this? This is the actual sample difference. The sample difference is at the center of the interval because that's your best guess of the true difference, and that's what makes the interval when you think y bar 1 minus y bar 2. So this is the sample difference, which is at the center of the interval. And then how do you find the margin of error? So the formula for this is upper plus lower divided by 2, if you average the two numbers. How do you find the margin of error? And what is it for this interval? What is the margin of error for this interval? We should know how to get that, even if we don't have like standard deviations and all that stuff. What is the margin of error of this interval right here? I made it nice and easy. Because you can go 250 if you write your interval. And say, write so what is the margin of error? What is the margin of error? Ooh, silence. Very close, but that's the full length of the interval. And a good check on this is to do 250 plus or minus 200, and then see if you got it. Briley, good luck on your test right there. Best of luck, you got this. So is that accurate right there? So the number one check, John, is to be like, let me write it in my like format of 250 plus or minus 200, and then if that recreates the interval, you've done it properly. Because the center plus or minus the margin of error creates the interval. The margin of error is just a plus or minus around the center of the interval. So what would be the margin of error? The margin of error is always half the length of the interval. Visually speaking, the margin of error always looks like this. So we've got 150, we've got 350. And so we have at the center of the interval the average of 250. So the you've done it. The margin of error is always half the length. So the margin of error is going to be 100 because the total length is 200. So does that make sense? Great job, Margaret and everybody. The margin of error is always half the length of the interval. And then when you write it out, you should be able to write it in a format of like 250 plus or minus 100, and 250 plus 100 is 350, 250 minus 100 is 150. So make sure you know that, and you can do upper plus lower, upper minus lower gets you the distance divided by 2, because this is the length of the interval. So that's how far they are away, 200 in length, and then half the length. So good practice. Let's do another interval interpretation right here, and this time we're actually going to use real data. So let me pull up some real data right here. Once again, you don't code in this class, but I love to code. I love to code every day. Here's how easy it is to make a confidence interval. Let's do this. I'm thinking right now. Can I do it with this? Prop test. I don't know if let me do a prop test. Well, sure. Well, we can get a summary of the data. Okay, summary of survey 10 and gender, and sample size is 399. So then we go here to prop test, and we go 386 out of 699, and there's the interval right there. Okay, did anyone see what I was trying to estimate? Okay, so here's what I'm trying to estimate. So what's the interpretation? And if you want, just make it nice and neat. It can be the following. So who's got us right here? Who's got it? What are we trying to estimate? So we're asking male, female, right? So what are we trying to estimate? Go back to your notes and see, do you see which interval I'm trying to do? Who knows which interval? 1, 2, or 3? Which interval are we trying to do? And that should be enough information at the bottom of the screen. It's also 95% if you're wondering. By default. It'll say in the output what it is. Like, it'll tell you. So what are we trying to estimate? Is it interval 1, 2, or 3? Which one is it? Is it 1, 2, or 3? Interval 1 deals with just categorical data. Interval 2 deals with just quantitative. And we're going to run out of room right here. But interval 3, I guess we really don't need that. Interval 3 deals with quant/cat. So which one of these are we doing right now? Which one of these are doing? And you have to think to the question. What am I asking people? I'm saying, are you male? Are you female? So which interval are we doing? Who knows? Take a guess. Don't worry. We're doing interval 1. You're right, Jordan, right there. We're doing interval 1. The true proportion of people who are female. So now, how do we interpret this? Try interpreting it. Remember, it's a 95% confidence. If you get to, I hope this is a free 5 points at the end of the test. And I'll even drop some hints. We'll do a little teaching the test, but I want people to try to write it out right here. And then I'll do a little more teaching to the test. So what would you write? It's a 95% confidence if you're wondering. What would you write? Try writing it out in the chat. Don't worry about being wrong. I'm going to go home and get some more coffee in a bit. More coffee. What would you write? How would you do it? And I will say this, the biggest learning moments are if you're going to say it out loud, write it down, or type it out. That's when you create more mental memories. I mean, you can see me say every single answer. Like, imagine listening to someone give a lecture on, like, quantum mechanics. But then imagine you could say the things they said from memory. That means you'd understand it to some degree. So try like I do. I am 95% confident that what are we talking about here? We'll give it a more moment longer, and then I'll say some answers. But the number one thing to do is to write it out, type it out, or say it. All different ways commit things to memory better. We are 95% confident that the true proportion of females is contained in the interval. There you go. That's it. Is it getting easier, John? Is it just like, yeah, I am blank percent confident that the true whatever we're talking about is contained in the interval blank to blank. And here's a hint, another teaching to the test moment. True or false, or yes or no? Will we ever try to estimate the sample mean, the sample proportion of the sample difference? Little teaching to the test. Will we ever try to estimate the sample mean, the sample proportion using an interval? Will we ever try to estimate those using an interval? Will we ever say, I am 95% confident the sample mean is contained in the interval blank to blank? or the I'm 95% confident the sample proportion is contained in the interval. I like it. Don't worry if you, I think everyone's gotten it right so far. The answer is no. That's like on those 201 interpretations where it says like, we know what the sample is. The sample proportion is right here. It literally says sample. I know we do estimate it, but that's not what the interval is trying to estimate. The interval is using the sample proportion to figure out an estimate of the true proportion. If you average these two numbers, what do you think you'll get? If you take the average of these two numbers, like can anyone solve this mathematically before I do? You take these two numbers right here, and then you go over here, and you divide by, and you go like that, and oh my gosh. Just some decimal differences. I think they're also using a slightly different technique than we do, but that's the center of the interval, and then the margin of error would be if you just did half the length of the interval. So there's the margin of error, positive or negative. You can write it either which way. So that's one way of doing it right there. Now let's do another one. And try to think of the easiest way. Let me see. Is it just... Oh, it is that. Why didn't I just think of that? Okay, so that's one way of doing it right there. Let's go to the next one. And really? Good. Okay, so what is the interpretation... There we go. What is the interpretation of this? Here it is. Can anyone understand this output right here? So we're doing another interval right now. And here's the question. So what are we trying to estimate? Interval 1, 2, or 3? What are we trying to estimate? Interval 1, 2, or 3? So this was the question. It was, what is your GPA? What are we trying to estimate? Interval 1, 2, or 3? Whoa. Interval 2. So try doing it right now. Just fill in the blanks. And remember, we never say the interval is trying to estimate the sample. It's a hint for the test. But how do we interpret this right here? Because I can do it. And also I changed a thing about it. If you notice right here, like it tells you like it. That's why I like the output. I think it's easy enough to read. And you can do it to 2 decimals. You can do it to 2 decimals. I'm fine with that. You don't need to type every decimal. I'll know you got it if you type this out. But these will be like, you get to this on the test. I am 70% confident that the true mean of GPA is contained in the interval. You got it. What happens when I go to like 99% confident? Will going from 70% to 90%, 99%. True or false? So true or false? The interval gets more precise. True, false. Nice job right there, Chloe. True, false. The interval gets wider. So the first one looks like false. The interval gets more correct. Because just think with your hands when we say 68 or yeah, 68, 95, 99.7, it gets wider when you go to more confident. So that's the empirical rule. It still works for these intervals too, that when you're more confident, you're wider. And that's actually what more precise is not meaning. Precise means tighter. So when you say an interval is more precise, if you're going out with your hands, which it would get wider, then it's not more precise. So the interval is less precise. So if we were to say the interval gets less precise, that is synonymous with wider. Does that make sense? I think, do people follow that? This is less precise. And let's do a fill in the blank right here. Another way to make an interval more precise is to increase what? Another way to make an interval more precise is by increasing what? Another way to make an interval more precise is to increase what? Increase sample size. Yep. And that's because sample size is associated with margin of error, where you have y bar plus or minus t star n minus 1 degrees of freedom, s over square root of n. So by increasing this sample size right here, if you increase this, these intervals are actually going to get smaller. You're going to bring in, because you're dividing by n. Does that make sense? The standard error is going to get smaller when that increases. If the standard error gets smaller, then the margin of error, which is everything after the plus or minus, also gets smaller because you're dividing by n. So dividing by n is an increase to sample size, and that makes a smaller standard error right there, smaller margin of error because you times by the t. The t directly relates to how what you are. The t directly relates to how what you are, and the star means you get to pick it. The t with subscript n minus 1 degrees of freedom relates to how what you are, how confident. Is this t down here the same as that t up there? Yes or no? Like you could just plug, could you just plug this value in? Do you just switch those around? Is that what you do? Do you just switch those around? Is that yes or no? Is that what you do? You can just be like, oh, we just take this t right here. And you could just flip-flop those t's. You could just flip-flop those t's. Yes or no? What do you think? No, don't worry if someone says yes now. No, those are not the same. This is a t you pick based on how confident you are. This is a standardized difference. This down here on the bottom is the difference standardized, and you're going to solve for t and then find the p-value. That's why the app has like solve for t from p-value or find p-value related to a t. So this t is the one you solve for. This is the t you pick based on how confident you are. So this t is totally up to the user. So it's user defined. And this one is solved for. You solve for this from a test, and then you find the p-value. And we won't have you find p-values on the, we'll do some tests coming up here. You won't find p-values on the test. You kind of have to know mechanically how to find them, and I'll come up with some good questions when we switch to testing coming up here next. So we only have one more, and I wonder if I can do it. Let's see if I can make the last one. We've done a lot of good theory on these, so really good review so far. Let's see, because I don't always do this type of thing in R. What happens if I do this? You didn't like it. Let me, I'm going to ChatGPT cheat this. Okay, 1 second. New chat. Gotta say thanks. Okay. If you notice, I'm trying to do the 2 sample t because y. Oh, really? That's it? Oh, I should have. It's y tilde x. Okay. There we go. It's tilde. That's all I was missing. Why am I trying to do the 2 sample t? Who knows why this is the 2 sample t? Can anyone explain right now this is the 2 sample t? Why? Because the 2 sample t involves a quantitative and a categorical variable. And we could also see this right here. I'm going to do it one of my favorite ways. Figure too large. What graphic is going to appear when I run this? This is a review again. What graphic is going to appear when I run the 2 sample t? When I run the 2 sample t with this code, what graphic is going to appear? So you can look at the screen to cheat. Ah! What graphic is going to appear when I run the 2 sample t? So you have to know the 2 sample t is a categorical x and a quantitative y. That's what the 2 sample t is. Side-by-side box plots. Boop. There you go. And it's got side-by-side histograms, normality plots. We're mainly focusing on this one right here, the side-by-side box plots. This is a lot more analysis than we need, or we're not even going to talk about it, but that's got it right there. And we could talk about the test coming up here next, but let's look at this output. Okay. So this is differences in GPA, and we're going to say 0.14 to 0.32. Who can just in one sentence explain what we're trying to estimate here? What are we trying to estimate right here? I'm highlighting words that might help you think about it. What are we actually trying to estimate? And then I'll probably interpret this one so we can start doing some testing. But what are we trying to estimate with this test right here where we have GPA, gender? What are we trying to do? What is this interval trying to estimate? And it already did the hypothesis test in the background. What is this interval trying to estimate? The true difference in the mean of GPAs between men and women. Exactly. Does that make sense? So we have evidence right now that who has a higher GPA, and it's kind of obvious if you look at this. But if you look at the way it was subtracted, do they show us here? I wish they showed it. It should be y bar female minus y bar male. Because the difference was found to be what? Positive. So I can deduce that the way these were subtracted was y bar female minus y bar male because we observe a positive difference. You can also see females have a higher GPA on average than males, and that's what would be at the center of the interval. So the interval is basically, go ahead and write the interval as estimate plus or minus margin of error. Who can do that in the chat? So write it now in the chat as estimate plus or minus margin of error. And just don't worry about rounding. I want to 2 decimals. So it should be something like, this is just some fake numbers, but you should write something like this right here. That's not actually the interval. But can you write the interval in its plus or minus format? So you have to come up with an estimate of the difference. And then, because we saw females had 3.25 on average, we saw males had 3.0 on average. That's not what I had. No cap. So you can do a lot of ways to find the estimate. The estimate is the difference observed between the two groups in the sample. Give it a moment more and then I'll show how to get it. Remember upper plus lower divided by 2? That gets the center of the interval. What's up, Coda? Let's see if anyone gets it. Upper plus lower divided by 2 gets the center of the interval. Is that it? It is 20. Yeah, nice. Yeah, and then if you do 23, so it's basically 23 right there, plus 0.09, and then minus 0.09, and look, you get the numbers, because remember we did that number, so when I minus this, does that make more sense? I hope this is helping John and others, that you're seeing like, oh, wait a minute, the center is at the average. You could have also just taken these values right here and subtracted them, and you'd get the same, like, down to the decimals. Is that starting to, because this is y bar female minus y bar male, which is then the center of the interval. That's the estimate. Because if you look at how the interval is calculated by doing, it would be y bar female minus y bar male, which is then the estimate of the difference, plus or minus, and the margin of error is the next part. Yeah, I like that. Dusting off some cobwebs. And then square root s sub 1 squared over n sub 1 plus, t. We forgot the t star. And then s sub 2 squared over n sub 2. Don't square the n. Don't square it. So that would be the margin of error is everything after the plus or minus. So that's the margin of error. And the standard error is part of it. And so the standard error makes up part of it. It's not the OE, but we're just doing that. And then the T is the confidence level right there. So understanding the margin of error is made up of those components. That's not M. That's not M. Oh, I did it another way. When I did this in class, because I don't want anyone thinking against M, especially if they're not listening or not listening, just watching. So that way it's like made up of those components. That's a better way, I think. Okay. So yeah, I am 95% confident that the true difference in GPAs between males and females is contained in the interval 0.14 to 0.32. Let's now put in this video connecting confidence intervals to tests. Should we know the formula is like critical values won't be used? I mean, like, let's talk. Let's bring this in right here. 43, 44, 33. Connecting confidence intervals to tests. So the idea of a critical value is the point at which you reject the null with a t or a z, or the t or the z used to create an interval. We have to give you t's and z's, or you have to know how to look at an applet picture. So what we would expect for this test, let's go to the apps. We would expect you to know certain things, like if you're looking at output. So let's take a look at this output right here. And let's pretend it looks this way. Okay, so this person went out and talked to students and asked them how much money they spend at Taco Bell. So does everyone hear this? I'll write this down too, I think would be good. So we've got this picture right here. They asked them, how much money do you spend at Taco Bell? And this is what they found. So this is more how we would want you to understand the knowledge. So someone went out and collected data from students on how much they spend on Taco Bell. They tested the value of $10, and this is what they found. Okay. So once again, my questions are more like, make sure you understand the theory. So first off, what can we learn from all of this? This is a little like backwards solving. What is the first thing you can learn from this? This is more like a level 5 question. If you know how to do it, it's not that hard, but what could you learn from this? So that says degrees of freedom are 49. Sample size was 50, exactly, and 50. So the sample size had to have been 50 because degrees of freedom equals n minus 1. Now, wait a minute. What do we know from n minus 1, also related to how much they spent at Taco Bell? What do you know from this? This is connecting your knowledge. I'm very proud. I'm like, yes, why did you do that? So what do you know from n minus 1, and you're collecting data on how much students spend at Taco Bell? What do you know from that? We're just seeing how much we could deduce from this. So when do you use n minus 1? How much they spend at Taco? Correct. Go a little more detail. Totally right. I know where you're going with this. I want you to explain it in a sentence. Like if I was quizzing you in person, I'd be like, okay, go in more detail. What do you mean by that? What do you mean by that? I know what you mean, and you're right. Keep going. I'm looking for the technique. I want you to say the technique we're using, like what kind of test we're performing, which that is true. Yes, what you've said. But what kind of test are we doing? So what kind of test? When you hear n minus 1, you know that's the degrees of freedom for this. When you hear you're testing how much they spend at Taco Bell, you should know you're doing this. So we are interested in the true mean. That is true. And t-test. T-test. Because Mr. T is mean. We always say Mr. T is mean if you're doing drugs. So we're testing this. We could also write out their null hypothesis. So down here, this helps us understand not the null, though. This right here means they did a what test. This would let us understand the alternative, and they did a what test. So that'll help us understand the alternative because the alternative decides the way you shade the curve. So they did a what test. The alternative decides the way you shade the curve. They did a greater than test. So then we can actually fill out the rest of this because the null always has the equal sign. And what goes in position 1 for these, or let me ask, what goes in position 1 and what goes in position 2? So what goes in position 1 for writing out the null right here? What goes in position 1? Who knows? Don't worry if you're wrong. We've gotten all right answers. I'm shocked. Let's throw 100,000 points right here. But what goes in position 1? Yes, the true mean of what people spend at Taco Bell goes in position 1. What goes in position 2? And the trick is whatever you write here goes right there. So you've already solved that. And then John on fire right there. Like that. Yes, John's got it. It's going to be $10 here. And that goes there. One more question, or maybe at least one more. What is 10 in notation? What is the notation for 10? 10 as a notation is called what? If we were to write something equals 10, what is it in notation? Great job, Bennett. What is 10 in notation? It is mu naught. Wow, nice job. It is mu naught used in the equation y bar minus mu naught over s over square root of n. We don't have all that information. X is the number of successes. That would be for proportion stuff. So this value over here is always the hypothesized value that the researcher decides, and this is the truth that we want to understand. We're saying that the true mean is equal to the hypothesized value. So in good guesses, good answers, good job. So what is their conclusion regarding the test, which is what we're going to with interpretations. So what is their conclusion regarding this test? What is their conclusion? So what is their conclusion? And assume 0.05 alpha unless otherwise stated. So Mubot's got right there in the chat. Let's go grab it. So we're going to bring this all the way down here. Oh my gosh. And one thing to know is if you go down this route right here, if you want to see, the only thing that's important is really the p-value. And do check if another alpha is stated. So you do want to see, are we using a different alpha level? But this is a p-value of 0.01. And so when you do this, you are going to say you either reject or don't reject the null. You can pick from that. State it. And this is fill in the blank on the test because my p-value of give correct p-value. We'll do more on that in a second. If you want to type this out while I'm making this pretty, is I'm highlighting everything that could be fill in the blank. I reject the null that students spend $10 on average at Taco Bell because my p-value of 0.01 is less than 0.05, which means I have evidence supporting our alternative. Yep, keep going. Yep. Great job, John. Yeah, everything you said is accurate. This means yeah, if you can do this, you'll get to the end, you'll be like, I got this. For alternative, that, state alternative. Ah, I knew it. I knew it. I'm gonna play some new Night Rain this weekend. Woo! Saw it last night, didn't have time to play it. State alternative. Okay. I reject the null because my p-value is less than 0.05. And then you want to say I reject the null that's, and then yeah. And remember, the null is at the true mean, not the sample mean. It's not that we reject the null that the sample mean is this. We're not making inferences about the sample mean. We're making inferences about the true mean that I reject the null. This means I have evidence that the true amount students spend on Taco Bell on average is greater than $10. Does that make sense? I know you only have 200 characters. That's why. And Chloe, great work. And John, great work. So we would go right here. And I want to also point out this, that if you say you reject the null, then you have to say your p-value is less than your alpha level. And you do have evidence. If you say you do not reject the null, then it's because your p-value is greater than or equal to, and you do not have evidence. So technically greater than or equal to. So this would be without an otherwise stated alpha. We always use 0.05 unless otherwise stated. I reject the null that the true average amount that students spend at Taco Bell is equal to $10 because my p-value of 0.01 is less than my alpha level of 0.05. This means I do have evidence for my alternative that the true amount students spend on average at Taco Bell is greater than $10. Now let's imagine we are given 3 possible intervals. 3 possible intervals for the truth. Are you ready? Interval A, interval B, interval C. Interval A goes from $7 to $13. Interval B goes from $5 to $9. Interval C goes from $12 to $16. Which one of these is the most likely interval that we would have had if we did an interval for this? Which one of these is the most likely interval, A, B, or C, if we were to make an interval for this? It is C. And does that make sense conceptually? Because think, you're saying I reject the null of $10. Well, that means A is wrong, because if you're rejecting $10 is true, A contains $10. Does that first one make sense? Like, I reject the null that $10 is true. Like, I'm rejecting that $10 is a possible value of truth. So you'd reject interval A because it contains A. And interval B, remember we're saying we have evidence that the true mean is greater than $10? Well, interval B is below $10. Interval C is the only one that contains values higher than $10 and also not inclusive of $10. So it would be logically that if you were making an interval, I'm not saying this is the interval, but this would be the only interval that would logically make sense from this. To say I am 95% confident that the true amount students spend on Taco Bell on average is contained in the interval $12 to $16. So if someone came back and reran a test and they said, I think students spend $15, what do you think would be a possible graphic? students say, or they say, I want to see if it's true that people spend $15 or they don't spend $15. So now think about this. With the interval we have, we're saying this is the connection here. The interval went from 12 to 16, and someone is running a test to say, I want to test if students spend on average $15, and what would be the sign of my alternatives? I'm just seeing if students spend $15 on average. I'm seeing, do students spend $15? What is the sign of my alternative? What is the sign of my alternative? Who knows? Not equal to, exactly. Not equal to, because do students spend $15? I never said more or less. I just said, do they spend $15? So now, what we would get right here, which of these graphics would be the correct curve to draw? Which of these graphics would be the correct curve to draw? Which of these graphics would be the correct curve to draw? Which of these graphics would be the correct curve to draw? Okay. How are you going to figure this out? Which of these graphics, A, B, C, D, E, which is the correct curve to draw? Well, you can narrow it down a bit. And here, I'll do a little more color coding. Correct. It's going to be on either side. And Benjamin's already said it. It's D. It is D. So remember that when you do a greater than test, you shade to the right. When you do a less than test, you shade to the left. So these would have to add up. Like if this is 5% of the curve, this is 95% of the curve. And if you do the does not equals test, this would be the less than test. The does not equals test would be 10% of the curve. So it's going to just be a reflection of whatever we have over here. So we do usually a dashed line versus a full line. And so you're wondering, well, if I narrow it down to the possible answers, well, then how am I going to, I was trying to do the highlighter. How am I going to pick between A, B, or D? Well, B has something interesting about it. The p-value looks very what for B? Large or small? You can type L or S in the chat. The p-value for B looks very large or small. How does the p-value for B look? The p-value for B looks very what? Very small. Now tell me, do you believe 15 is a possible value of truth? Yes or no, and why? I'll answer the why. But do you believe 15 because I am 95% confident, we'll pretend it's 95% confident, that the true mean amount students spend at Taco Bell is contained in the interval $12 to $16. So since it's contained in the interval, logically, if this is a 95% confidence interval, so if this is 95% confidence, values inside of it cannot be rejected with an alpha of 0.05. It's an analogous thing to a two-tailed test when running not rejected on the two-tailed test on 0.05. That's because the test and the interval basically do the same thing. When you do a two-tailed, where you have the inside for the confidence interval and the outside for the test, they kind of line up on how they create. So a hypothesis test, if you do a 90% confidence interval, that's the same as a two-tailed hypothesis with what alpha? 90% confidence is the same as running a two-tailed hypothesis with what alpha level? Bye, Chloe. Good to see you. It'd be the same as running it with an alpha level equal to what? On a two-tailed. So if you have 90%, not 0.05, that's for this one over here. 95 is related to so if you notice the trick right here, do you see the trick? So think about how this relates. Because if you have 90% inside, then you're looking down here at this. Yeah, exactly, 0.1. Mm-hmm. Yeah, so it's the remaining outside. Does that, I think that makes sense now. So it's the remaining outside. It's for the two-tailed test. because confidence intervals do the inside and two tails does the outside. So since we know we can't reject it here, we can't be having too big of a result, too far away, too small of a p-value. Yeah, no, 0.05 on either side. And you could actually do a one-tailed test of 0.05 alpha, so that you can do it on the one-tailed, like a one-tailed greater than test 0.05. But the two-tailed naturally aligns with 90% inside, 10% outside, so it naturally aligns with that being a total. And so the thing is it's D, because this one would actually be if you landed right on 15, because this would have to be 15s at the center of the interval, which it's not. This would have been, if this was it, we would have like 15 to 17 to 13, but we don't. We have to have landed a little bit of ways, but not small enough to reject the null. So the p-value here would have to be something like p-value of 0.20 or something. It could be any sort of p-value above 0.05. So since it's a 95% confidence interval, the p-value has to be greater than, because the value is contained in it. Does that make sense to everybody? The p-value over here would have to be, so I should have given p-values to all of these to maybe make it easier. 0.01, p-value of 0.05, we'll make that a half. P-value of 1, that means you landed right on the result. So it'd have to be the center of the interval because you found the most likely thing. And then this would be p-value equal 0.05. We'll make that the other side of the other curve. So the only one that works is we don't reject it, and then we didn't land right on it. A is a little tricky. You have to understand that we didn't land right on it. Let's do like 2 more interpretations. So let's do more interpretations. Okay. One of my favorite ones to interpret is the chi-squared. So let's do more test interpretations. Okay. Chi-squared is so cool. It's so easy to run in here. Let's run a few. They're so easy. So the chi-squared test of independence. Let's pull up survey 11. And if you want, you can tell me one of these to use. Pick a variable, x what? We're doing chi-squared, so you got to know what to pick. X what? We're doing chi-squared, so you got to know what to pick. X number what? We're doing chi-squared, so this is actually a quiz question. What do you pick? It's chi-squared. So chi-squared requires what? So pick one of the ones to do. So you have to know. Categorical, exactly. So it's factors inside of R. So if it says factors with levels, that's what categorical is inside of R. That is not on the test, but pick a categorical variable. X whatever. Just tell me X number and I'll find it. So we don't have to type it. You say X this. We can't use like how many people you send text to. You can't do that. X49. Wait. We can't do X49. We could do that one for like a 2-sample T. So we could see who's read more Harry Potter books based on gender. So we could look at how many Harry Potter books you've read based on your gender. That would be a 2-sample T right here to compare. And you could see on average, men have read, what? Look at this. On average, men have read more Harry Potter than females. That is, but the difference is not the difference in medians is statistically significant. It is skewed. So yeah, X30, let's look at X30 is, are you a morning person based on gender? Let's do that. So are you a morning person based on gender? And here it is. Okay. So what is the null hypothesis for this? What is the null hypothesis for this? No worries, John. What is the null hypothesis for this? We have morning person and gender. And for the chi-square test of independence, it's super easy to write the null. So you got morning person, gender. Remember, it's the chi-square test of independence. So what would it be? What would the chi-square test of independence be? Being a morning person is independent of gender. Oh, remember, the null is that they're independent. The alternative is that they're not independent. So the null is always they're independent, which means they have no relationship. Like, it doesn't matter what your gender is. Being a morning person is not related to that. That's what we're saying was like someone's like, I bet I can tell if you're a morning person based on if you're male or female. And you're like, it's not related. The alternative would be that they are related, that there is evidence of an association, that they're dependent to some degree. So remember, the null is they are independent. The alternative is not independent, meaning associated to some degree. So when you run the chi-squared test of independence, it ends in a p-value. And you can kind of see the answer over here to the question. So explain to me, remember our interpretation? How would we go? Well, first off, let's do our practice. When the p-value is low, reject the null. When the p-value is high, just let it fly. So what do you do to this null? When the p-value is lower than 0.05, reject the null. So what do you do to that null? Or what do you do to that? I guess the null, but the p-value is going to do what to the null? When the p-value is low, reject. Oh, you let the null fly. You just let it be. You say, hey, null, you're good. So remember, the null hypothesis was, gender is independent of being a morning person. So what are we going to say? I don't reject that gender is independent of being a morning person because my p-value of 0.526 is way above my alpha level of 0.05. Finish it off for me right here. So you're on the last part. And you could say not independent, but maybe phrase it a little bit differently. How would you finish off the last part of this? Like I said, I do not reject the null that gender is independent of being a morning person. I do not reject the null that gender is independent of being a morning person, as in I still believe that they're unrelated because my p-value of 0.526 is way above my alpha level of 0.05. And so this means what? You could say the ending in more like what it means because the ending could be the alternative that they are not independent. So what do we have? And then we'll do like 2 more of these. Hypothesis testing. Once again, if you're at home, try writing it down or saying it out loud. It really helps. I've had people tell me that they're like, I didn't realize it, but when I was saying it, it helped. It's a big help. Think about watching someone playing piano or playing piano. When do you learn more piano? We don't have evidence. And good review right here. You ready? Yeah, we don't have evidence. So whenever you do not reject, you do not have evidence. Does that make sense? So it's a good mnemonic to remember that if you go down this path of not rejecting, which is also fail to reject, so you don't have evidence. So when you do not reject, you do not have evidence. When you do reject, you do have evidence because your p-value was less than it, because the p-value rejects the null. So when you do reject the null, you do have evidence. When you do not reject, and what's a synonymous thing with do not reject? Good job right there, Bennett and Margaret and John. What is a synonymous way to say I do not reject the null? So what's another way of saying I do not reject the null, which classically people say? I like to say I don't reject the null. I think you should know that. But then you have to know the fail to reject, which another way to say it is I retain the null. Like I do not reject, I retain means to hang on to. But I like don't reject because if I tell my wife, she's like, hey, did you feed the bunnies this morning? Because I had to do that. And I say, I failed to feed the bunnies. What does it mean if I say, my wife's like, did you feed the bunnies? And I say, I failed to feed the bunnies. What does that mean? It's like an old school way of saying things. I failed to feed the bunnies, which I didn't. I did not fail to feed the bunnies. I did feed the bunnies. So if I say I failed to feed the bunnies, it means I did not feed the bunnies. So failed to do something means you don't do it, like fail to reject. Exactly. So when we say I fail to reject the null, I preferably just say I don't reject the null. And I mean this. We don't like accept. Oh my gosh, don't write accept. Let me just put this as a note. Like I feel like another teaching the test moment. We never accept things. Never. 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 No one gets that besides me and 90s kids. We do not accept the null. We do not accept the alternative. We reject the null or we don't reject the null. We have evidence for the alternative. We don't have evidence for the alternative. We don't accept the null because if you accept the null, that means like you think it's true. No, we don't know what truth is. We don't know what truth is. In statistics, we're trying to estimate truth from samples, and we only have a reasonable belief that the null is possible. Remember, we're looking at the probability of our results or results from a stream given the null is true. So I should say, because I heard myself say something that I'm like, statistician's going to yell at me. We only have a reasonable belief that our results were likely given the null is true, because that's what a p-value is. It's the probability of our results or results from our stream given the null is true. So what we saw was a likely result given the null is true, versus when we reject the null, what we saw was an unlikely result given the null is true, but we can always make a type 1 or type 2 error. So there's always the possibility of errors with these tests. Okay, let's try another one. How about, let's switch these variables. Let's try 2 more. Chi-squared test of independence, I'll tell you the null, but what do you think here? Give me x whatever. X whatever. X, whatever. Remember, it's the chi-squared test. This is the count data condition. Must involve two categorical variables. Two categorical variables. What do you got? Mubot. What do you got? X15. Well, we can do that, but this would be different. This would be the two sample t-test. The way it's set up right there is two sample t. This is a two sample t-test. It's mad about the graphics or something. I might have to reset it, but won't worry about that. It's something happened with the graphics. But this would be a two sample t-test right here, t-dot test. That'd be a two sample t-test because you have a quantitative and a categorical, and we have evidence of a difference. Look at that. So there'd be evidence of a difference right here. So we could actually do this one. So good question. Interpret this. What would the null hypothesis for this be? This is, we're talking about how many people you talk to on the phone and also gender. What would the null hypothesis for this be? What would the null hypothesis for this be? Does anyone know the null hypothesis? What is the null? So we've switched from the chi-squared because now we have a quantitative variable and we have, stop being weird, and there we go there. So this would lead to, on the quantitative scale, or we could do down here gender, you got male or female, male, and then the quantitative scale up here would be number of people, so num of people, and so you'd have box plots, and the difference is negative. Well, males are higher. So what would the null hypothesis be? The null hypothesis for this, the null hypothesis would state, remember the null has the equal sign. The alternative, we could test if there is a difference, and the alternative would have the does not equal sign. And the easiest way to write this one is mu male minus mu female. And you can always do mu male minus mu female equals 0. That's an alternative way of doing it. The alternative, well, that's not the alternative. It's just another way to write the null. The alternative is going to be mu male not equal mu female. Exactly. The true difference in means. Exactly. And yep, that's what you wrote right there. The true difference in means is equal to 0. And then I did it where you can just take this and put it to the other side via mathematical addition. And so now, do we reject the null or fail to reject the null? So here's the p-value. So do we reject the null or fail to reject using point? Let's do alpha 0.02. Alpha 0.02, do you reject the null or fail to reject the null? Reject or fail to reject the null. Alpha 0.02. What do you do? So rejecting the null is p-value less than alpha. And we have p-value of 0.013 less than the alpha of 0.02. So we reject the null. There is evidence to reject the null. So can anyone write it out? I might say this one. So I reject the null that the average amount that males and females talk to people on the phone is the same, or there is no difference, because my p-value of 0.01359 is less than my alpha level of 0.02. This means I have evidence that there is a true difference between, on average, how much females and males spend talking to people on the phone, or like how many people they speak to, or is it number of people you talk to on the phone. But watch this. If I change this right here to a 98% confidence interval, is it confident or here we go? I did it earlier. I did it earlier. Where was it? I changed the confidence level. Where did I do it? Oh, no. I swear I did it. Is it level? No. Let me find out. It's cheating. Okay. Gonna get the answer. Conf level. What? That's what I was trying to type. This is not autocomplete. Conf.level. Weird. It's not auto-completing. Okay, that's why. Well, I was going to... Oh. Well, wait. So maybe it doesn't work. What typo am I making here? Oh, I didn't do the equals. So what I was going to say is, notice how the interval does not contain 0. Because a 98% confidence interval is the same as doing a 0.02 alpha. But if I change this to 99% confidence, what's going to happen to the interval as it gets wider? Can we reject this at the 0.01 level? Yes or no in the chat. Can I reject this at the 0.01 level? 0.01 level. Can I reject it at the 0.01 level? Could I reject it at the 0.01 level? Which means p-value less than 0.01. Can I reject it at the 0.01 level? What do you think? No. So do you know what that means? That means on a 99% confidence interval, it must contain the hypothesized value of 0, which means this interval is now containing 0. Do you see this? That the interval goes through 0 because it goes from negative to positive. So I knew as I went from a 98 to a 99, when I can't reject 0 because 0 is the hypothesized difference according to the null, we can no longer reject 0 when this interval gets really wide. And when it goes all the way out to 99% confidence, that'd be the same thing as running it at a 0.01 alpha level. So we can't reject it at the 0.01 alpha level. So do people follow that? You could not reject this at the 0.01 alpha level because this p-value. So a 99% confidence interval would contain the hypothesized value of 0. And that's how confidence intervals relate to tests, that you can just think of the alpha level used and then understand the interval would not contain it if you would reject that value, if you're doing a two-tailed test. Well, I think we've done all, like, I guess we'll do a prop interpretation. We haven't done that one, and we'll finish off right here. So, prop test. Let's say Brian believes that half of UT is female. And he wants to see if it's different from that. What did I do? Oh, I actually have to go grab the values again. Okay. What do you do? What would be the null hypothesis here? So what would be the null hypothesis? It is doing with a chi-squared, a little different than ours, but we could also do this by hand. What would be the null hypothesis for this test? Brian is saying he believes that 50% of UT is female, which, remember, you can pick any value you want for the null. So what would be the null? What would be the null? He observed that many successes in this many trials. What would be the null? What would be the null? Brian believes 50% of UT is female. Well, yes. And then does anyone want to say the notation? I mean, John has it right there. So the null would be, remember, the null always has the equal sign unless we're doing the chi-squared. Then we do blank is independent of blank. So the null has the equal sign. So what do we put here? And then the alternative, you pick the sign based on the way the researcher's testing. So what is it going to be? Exactly, John's got it. The proportion of people who are female is 50%. And whenever we write the nulls in notation, it's going to be either p mu or mu1 minus mu2, and then is equal to the hypothesized value. And then do remember, always put the value we're testing. A lot of people have to, like, equals 50%, true, but the proportion of people who are female is 50%. So since I didn't state which way I'm doing the test, it's going to be the does not equals alternative, and then you simply carry these down. Whatever you put here goes here. Whatever you put here goes here. And what in notation is this? What is the notation for this? Like, this 50% is equal to what? Does it say it right there? Actually, it does say it. Well, kind of. And this is the alternative, if you notice. Like, this is saying. So what in notation is that? This says the alternative hypothesis. It's P naught. P naught. The hypothesized truth. So that's P naught right there. And so what's the end result of our test? When you go here, what is the end result of our test? Using the general alpha of 0.05, what is the end result? blocking it. Reject the null. Exactly. And so you would say, I reject the null. I have evidence, or I reject the null that the true proportion of students who are female is 50%. I have evidence for my alternative that the true proportion of females is not equal to 50%. And then I want you to see, what do you notice about this interval, which also confirms what you're saying? What do you notice about this 95% confidence interval, which also would be in line with what you're saying when you say, I reject the null that 50% of UT is female? What is in line with your thinking that, like, is related to this? Exactly, 50% is not in the interval, or we should maybe put this sort of to the side on this side. So 50% is below the interval. So 50% is outside the interval, hence a value that we do not believe is true. We could have made an error. What is the only error we could have made? Let's finish off with the errors right here, because maybe people haven't reviewed this enough. And so let's go here, 121.33, reviewing errors. Okay, so what is the only error we could have made right here? We said, I think there's evidence that there's more, or that the true proportion of people who are female at UT is not equal to 50%. The only error we could have made is what? The only error, we might be right. We might be right that it's not 50%. So there's only two possible scenarios. We're either right that it's not 50%, or we've made an error. The only error we could have made is what? We might go to the main screen for this, or we'll do it here. The only possible error we could have made is what? So let's review the types of errors. There's two types of errors. There's a type 1 error and a type 2. Yes. And the answer is we could have only made a type 1 error. Because in a type 1 error, the null is true and we reject it. In a type 2 error, the null is false and we failed to reject it. So one of the easy ways to remember the type 1 error is you just hold up 1 and then you make a T and you always talk about the null. So I want you to think of this. If the null is true, the correct choice is to what? This is the correct choice. If the null is true, the correct thing to do is what? The correct thing to do is what? The correct thing to do, not reject. And this is not our mnemonic. The error is when someone rejects the true null. That's the error. The type 1 error is when someone failed to reject. Yeah, we'll put a failed to reject. Failed to reject. Does that, who feels like, okay, that makes sense. Like, if the null is true, you shouldn't reject it. If the null is true and you reject it, you've made an error because the null was true and you rejected the truth. So if the null is false, the correct choice is to what? If the null is false, the correct choice is what? If the null is false, this is not our mnemonic, but if the null is false, the correct choice is what? It's gonna reject it, right? So the error is when someone fails to reject the false null. So the error is failing to reject a false null, which is the type 2 error. And this is where in the type 2 errors, there's 2 Fs. In the type 2 error, this is called type 2 error. There's 2 Fs in the type 2. And this is type 1 error. So the top ones are the correct choice. Like, you should do that. If the null is true, don't reject it. If you do, and you don't know you've done this, you're like, why would I do that? Why would I do that? Imagine like, imagine you're playing basketball and we're losing. Okay, so we're losing. Oh my gosh, it's the end of the game. And it's 100 to 94. And there's like 60 seconds on the clock. And you think, we need evidence to do something different. So this is, the null is keep going on. The alternative is put Brian in. Okay. So what happens is you decide to put Brian in. So what have you done? If you put Brian in the game, what have you done? What have you done if you're like, we need to put Brian in the game? Like we're down by 6 points. What have you done if you decide to put Brian in the game? I mean, we got to put Brian in the game. Brian's saying he's ready to go. What have we done? We've rejected the null. So at this point, we've rejected the null. Now, if we win the game and everything's awesome, did you make an error? If we win the game and we come back, probably not. We'll just pretend. We'll be in pretend. This is real pretend world. Did you make an error? Do you think you made an error if we win the game? If we win the game, you rejected the null. No, we were correct. You made the correct choice. Like you're like, sometimes you can find these things out. Sometimes you know. Sometimes you'll see the other scenarios, but sometimes you know. So what error would this be if we end up losing the game even worse? Like Brian gets us disqualified from the season because he pushes over the players on the other team. Like Brian's like, I got this, I can win. And I just walk in and start shoving players. And the coach is like, what are you doing? And I'm like, we got this. We just knock them over. And then they're like, look, your team's disqualified from the season. It gets even worse. You're like, what did we do? What did we do? We made a what? We definitely made a what? We definitely made a what? We definitely made a what here? So we rejected the null, and we shouldn't have. So, because I mean, things got worse. We made a type 1 error. That was a type 1 error. Because in a type 1 error, the null is true, and you reject it. So although we were losing, or maybe we would even come back. We don't know if we would have won, but at least it would have kept going on the way it was going on. So think about the type 2 error. Explain to me a type 2 error in this scenario. What is a type 2 error? Remember, in a type 2 error, the null is false. It is false that we should keep going the way we're going, but we are going to do what? So in a type 2 error, the null is false. We shouldn't keep going. What does that mean? And we fail to reject the null. What does that mean? So Brian's on the sideline. He's like, put me in, guys. Guys, put me in. Put me in. And what happens? So the null is false, but we fail to reject it. So what happens here? What does this mean in context of this? We don't put Brian in and we lose the game. And more specifically, you're right. We don't put Brian in and we lose the game, and then it means that we should. I think you've got it. We don't put Brian in and we lose the game, and we would have won. You keep going without Brian, but the correct choice would have been to reject the null because the null is false. We should put Brian in. Does that make sense? But we would have won with him in the game. It seems like we don't know this, and that's why we don't know if you say, how would you know that? You never know sometimes if you make these errors. You don't know, and you might find out if things get worse, and you're like, oh, that looks to be an error, and it's actually possible that you could just be in a weird sample result that from the truth. You never know if you made the true choice a lot of times. You'd only have evidence from what you observe from making a choice. Like, did I make an error? Like, if you don't put Brian in the game, you stayed with the null, and if you you'd never know that you would have won or something. So yeah, but the null could have been true. Like it could be that Brian was gonna do those crazy things, so you made the correct choice by not putting him in the game. So even if you lost, you could have made it worse. It's not that you're that Brian guy. So does everyone think they understand type 1 and type 2 a little bit better? I hope. In a type 1 error, the null is true and we reject it. In a type 2 error, the null is false and we fail to reject it, just in a quick and easy way. And you don't always know. And it's not that one is usually worse than the other. It's scenario driven. It's like, yeah, it's clicking. Well, we've gone an hour and a half today. I want to say a huge thank you. We'll try to probably do a big review on Monday also. I'll come in. Gets me out of the house. You can't play video games too much, right? Or maybe you can. Digital faculty consultants on Wednesday. I don't know why I sing everything. Game design. What? $1 million in NSF grants. What? Awesome. Well, thank you so much, everybody. I had a great time today. Until next time, bye for now. Bye. We've almost got these new intros ready. We're almost there.
This has been going for like 20 hours. This ends now.